Okay, grade 8, now we're going to be doing problem solving in the section on measurement. And you'll see how it all comes together now. This is a really fun section for all of those thinkers out there. Okay, let's go straight into example 1. A farmer can fence off a length of 200 meters, or he has a 200 meter length fence, so it's not in the ground yet. He can keep 1 chicken for every meter squared he can fence off, right? So for every meter squared, so that's 1 by 1 meters he has, so 1 by 1 meters, he can keep 1 chicken in there. That's 1 chicken. Okay, so the length of the fence is 200 meters. How many chickens can he keep if he made a square out of his fence? Okay, so we know that the fence is going to be, or a square is equal sides. So there's 200 divided by 4 equal sides, 200 divided by 4, and that is equal to 50 meters each length. So let's just draw the square. We have our square coming down, and each side is 50 meters because we only have 50 meters of, or 200 meters of fencing. So it's 50 meters, 50 meters, 50 meters, and 50 meters. Okay, perfect. You can see there's 200 meters of fences, 200 meters of fences used. Now, what's the area of a fence? Area of a square. An area of a square is equal to s squared. What is s? That's 50. So what's 50 times 50? What's 5 times 5? That's 25. Plus another 2 zeros is 2,500 chickens. Yo, that's a lot of chickens that he can keep in that area. Okay, so we have that he can keep 250 chickens in a square. How many chickens could he keep if he made a rectangle of length 80? Okay, so now we're going to try and make a different configuration. We're not going to use a square. We're still using our 200 meters. So if the rectangle is going to have a length of 80, so we have our rectangle that we're going to draw here, right? We're going to assume that there's a length of 80 meters, and 80 meters. Okay, so 80 plus 80 is equal to 160, right? So there's 160 meters of fence we've used. So we only have, how much fence do we have left? 200 minus 160 is equal to 40 meters. We've got to divide that by 2 because we're going to put it on each side. So that's 20 meters of fence on each side. That makes sense. 20 meters, 20 meters. We can check the perimeter. That's 80 plus 20, that's 100, and 100, that's 200. That's perfect. Right, so we have that. Now, how do we figure out the area? Area of a rectangle is equal to length times height, and that is equal to a length of 80 times a height of 20. What's 8 times 2? That's 16. Plus 2 zeros is 1,600 meters squared, which means there's 1,600 chickens. Right? So we can actually see that he has a smaller area if he configures the cage differently. So at the moment, we definitely would rather want to use a square. Let's have another look. We have our square with 200,500 chickens. We have our rectangle with 1,600 chickens. How many chickens can he keep if he made a circle? So now we need to make a circle. Now, the circumference of the circle will equal 200 meters. That makes sense because it is the length of the fence. So from here all the way around, back to the start is 200 meters. We have a radius. Okay. So now we need to figure out the area of a circle. The area of a circle is equal to pi r squared. Okay. But we don't know r, but we do know c. What do we know? Circumference is equal to 2 pi r. So that means that r is equal to circumference divided by 2 pi. You're going to need your calculators here because circumference is 200 meters divided by 2 times pi. You can see that 200 divided by 2 is 100. So that is simply 100 divided by pi. And please get out your calculator. You will need this, but if you don't have it with you, I'm going to simply do it for you. And 100 divided by pi is 31.83. So that's 31.83 meters. Okay. So now the area is equal to pi 31.83 squared. Let's calculate 31.8, or let's calculate that whole sum, pi multiplied by 31.83 squared, and that is going to equal 3,000. Oops, let's write that again. We've gone too far forward. 3,182. 0.9, but we can't use a 0.9 because you can't have a ninth of a chicken. So there's going to be, remember that's meters squared. So that's 3,182 chickens. Sure, that is a lot more. As you'll figure out, a circle is the most efficient way to get the biggest area with the smallest amount of perimeter or circumference. And that is what we've learned here in this example. Let's go on to another example. You have a triangle with the following length sides, 6, 5, 5. Using a string, what is the area of the triangle? Okay, so you've used a string to create this triangle. We know that the lengths are 6, 6, and 5. We can see that that's an isosceles. We have a 5, we have a 5, we have a 6. Remember, this is a piece of string that we want to run around. If we want to solve the area, we need to figure out this height here. We can see it's isosceles, so that must be 3 and 3. What's our 3 and 5? We know that that must be a 4, because our 3, 4, 5 triangle. Remember your 3, 4, 5 triangle. So area is equal to a half base multiplied by height. What is your base here? Your base is 6, so it's a half of 6. What is 6? Half of 6 is, we're going to calculate the next. Half of 6 times height, which is 4. So that is 3 multiplied by 4, which is equal to 12 units squared. Do we have a unit? We do, so that is equal to 12 centimeters squared. Okay, so we've got the area of our triangle. Now, we calculated the area of the triangle. Now we want to say, how many of these triangles would fit into a rectangle of 80 millimeters of 60 millimeters by 80 millimeters? Okay, so let's quickly convert that is to 6 centimeters times 8 centimeters. Okay, so our triangle, remember it was, we had our triangle, and that was 6 and 5 and 5 and a height of 4. Right? Now we want a rectangle where the base is 6, that's fine, and we have a height of 8. Oh, there's our height of 8. We can see that that is double. So that is 4 and 4, which makes a total of 8. We can quite easily see that, remember, with a rectangle, the triangle covers half the area. So we know that there's the area of the triangle. And if we could draw an upside down triangle here, we could say, there's a triangle, there's another triangle here, and there's a last triangle there. So there would be 4 triangles that could fit perfectly into that area. Okay, and lastly, if you made a circle from that string, what would the diameter of the circle be? Do we know the circumference of the circle? Yes, we do, because the circumference is equal to the length of the string, which is 6 plus 5 plus 5. That's the length of our string, and that is 16. So the circumference is 16 centimeters. Right? What else do we know about circumference? Circumference is equal to 2 pi r. What is 2r? We know that 2r is equal to diameter, so circumference is equal to pi times diameter. So if we want to solve diameter, we divide by pi, we divide by pi. Those cancel out. So then we have d is equal to circumference over pi. What is our circumference? It's 16 centimeters. Divide by pi, you're going to need to get your calculator out. So you're going to go 16 divided by your pi, and you're going to get the answer 5.09. And that is what, sorry, that was a pi over there, and that is equal to 5.09 centimeters, and that is our diameter. Try and calculate that back to see if you get the same circumference again. Well done, grade 8. That was problem solving. Now we're going to move on to 3D shapes, which is also loads of fun.